In this podcast episode, Andrew Huberman opens the discussion by highlighting the vagus nerve, also known as cranial nerve 10, as one of the most fascinating components of the nervous system. Unlike the typical notion of nerves as simple wires connecting two points, the vagus nerve is an extensive and complex pathway that links the brain to many parts of the body, effectively acting as a nervous system within the nervous system. It spans from the head and neck down through the chest and abdomen, reaching even the lower intestines, making it unique among cranial nerves. Huberman emphasizes that the vagus nerve is not only vast anatomically, but also functionally diverse. It plays critical roles in regulating mood, alertness, immune function, and learning. Recent advances have mapped its pathways in greater detail, revealing how specific branches can be targeted to achieve different physiological and psychological outcomes. This nerve's accessibility and the ability to influence it through simple, non-pharmacological methods make it a powerful tool for everyday health and performance. A key point Huberman makes is that the vagus nerve is a mixed nerve, containing both sensory and motor neurons. This dual nature is often overlooked in popular discussions, which tend to focus solely on its calming, sensory functions. Sensory neurons in the vagus nerve carry information from the body's organs, such as the heart, lungs, and gut, up to the brain, conveying mechanical and chemical signals like stretch or acidity. Conversely, motor neurons send signals from the brain back to the body, controlling muscle contractions and organ functions. For example, motor fibers regulate the gut's motility and the heart's rhythm. Understanding this bidirectional flow of information is crucial because activating different branches or types of neurons within the vagus nerve can produce opposite effects, such as calming or alerting the nervous system. Huberman situates the vagus nerve within the broader context of the autonomic nervous system, which balances sympathetic, alertness and fight or flight, and parasympathetic, rest and digest activity. The vagus nerve is primarily classified as parasympathetic, but this classification can be misleading. While some vagal pathways promote relaxation and calm, others can increase alertness and sympathetic activity. This nuanced understanding challenges the common myth that vagus nerve activation always leads to calmness. Instead, the vagus nerve acts as a dynamic regulator, capable of shifting the body's state depending on which pathways are engaged. This balance, or seesaw, between sympathetic and parasympathetic activity is continuously modulated by the vagus nerve to maintain homeostasis. One of the most actionable insights Huberman shares is the vagus nerve's role in heart rate variability, HRV, a marker of autonomic balance and cardiovascular health. The vagus nerve's motor fibers project to the sinoatrial node of the heart, where they slow heart rate through parasympathetic signaling. This deceleration pathway is essential for preventing excessive sympathetic activation and maintaining physiological balance. Importantly, HRV is not just a passive measure, but can be actively influenced through breathing techniques. The vagus nerve coordinates heart rate with breathing cycles, speeding up the heart during inhalation and slowing it during exhalation. By deliberately extending exhales or performing a physiological sigh, 2 inhales followed by a long exhale, individuals can enhance vagal tone, increase HRV, and promote calmness. Regular practice of these breathing patterns strengthens this autoregulatory pathway, improving both daytime calm and sleep quality. Huberman reveals a fascinating mechanism by which physical activity engages the vagus nerve to increase brain alertness. When large muscles, especially in the legs and trunk, contract during exercise, the adrenal glands release adrenaline, epinephrine. Although adrenaline cannot cross the blood-brain barrier, it binds to receptors on sensory vagal fibers, which then relay excitatory signals to the brainstem's nucleus tractus solitarius, NTS. From the NTS, signals activate the locus coeruleus, a brain region that releases norepinephrine widely across the brain, boosting alertness and motivation. This pathway explains why even when feeling lethargic, engaging in physical activity can rapidly increase mental energy and focus. It also underscores the vagus nerve's role as a critical link between body movement and brain state, providing a natural, non-pharmacological way to overcome brain fog and enhance cognitive performance. The vagus nerve also plays a pivotal role in neuroplasticity, the brain's ability to change and adapt through experience. Huberman explains that adult neuroplasticity requires both alertness and focus, which are facilitated by neuromodulators like norepinephrine and acetylcholine. The vagus nerve, through its connections to the NTS, influences both the locus coeruleus, norepinephrine release, and the nucleus basalis, acetylcholine release. This dual activation creates an optimal brain state for learning by enhancing attention and opening a window for plasticity. Studies in animals and humans, including stroke patients, show that vagus nerve stimulation can accelerate motor recovery and cognitive improvements. Huberman suggests that timing learning sessions to follow bouts of exercise, which activate these vagal pathways, can maximize neuroplasticity and learning efficiency. Another remarkable function of the vagus nerve is its role in communicating serotonin levels between the gut and the brain. Although about 90% of the body's serotonin is produced in the gut, this serotonin does not cross into the brain. Instead, serotonin in the gut binds to receptors on vagal sensory neurons, which relay signals to the brainstem's NTS and subsequently to the dorsal raphe nucleus, the primary source of brain serotonin. This pathway means that gut health and serotonin production directly influence brain serotonin levels, impacting mood and well-being. Huberman highlights the importance of maintaining a healthy gut microbiome through diet, particularly by consuming low-sugar fermented foods, and ensuring adequate dietary tryptophan, the precursor to serotonin. These lifestyle factors can support serotonin production in the gut and via vagal signaling promote balanced serotonin levels in the brain. While the vagus nerve is often associated with calming effects, Huberman clarifies that only specific branches and pathways produce this parasympathetic response. One well-known method is stimulating the sensory vagal fibers around the ear, such as by gentle rubbing behind or inside the ear canal. This mechanical stimulation activates calming vagal pathways but tends to produce modest effects rather than dramatic shifts in autonomic state. More robust calming can be achieved through breathing techniques like the physiological sigh or extended exhales, which engage vagal motor pathways to slow heart rate. Additionally, certain mechanical stretches of the neck that activate vagal fibers can promote relaxation, though these effects are generally less potent than targeted breathing exercises. Huberman introduces an intriguing and accessible method for vagal activation: humming. The vibrations produced during humming stimulate the vagus nerve branches that innervate the larynx and throat. However, the effectiveness depends on how one hums. Extending the H sound before the M in a hum produces deeper vibrations in the throat and chest, which more effectively engage vagal pathways. This technique is akin to gargling and is used by singers to relax and access lower vocal registers. The slow exhalation involved in humming also contributes to parasympathetic activation by slowing heart rate. Huberman encourages listeners to try this method as a simple, non-invasive way to calm the nervous system and enhance vagal tone. Throughout the discussion, Huberman stresses that the vagus nerve's functions extend far beyond the traditional rest and digest label. It is involved in a wide array of physiological processes, including immune regulation, mood modulation, cardiovascular control, and neuroplasticity. This complexity means that interventions targeting the vagus nerve must be precise to achieve desired outcomes, whether calming, energizing, or enhancing learning. He also acknowledges the contributions of earlier theories, such as Stephen Porges' polyvagal theory, which laid important groundwork in understanding vagal function. However, recent research has expanded this understanding, revealing new pathways and mechanisms that offer more nuanced and actionable insights into how the vagus nerve can be harnessed for health and performance. Huberman provides several practical, science-backed tools for engaging the vagus nerve in daily life. These include the physiological sigh breathing technique, deliberate extended exhales throughout the day to improve HRV, mechanical neck stretches to activate vagal fibers, gentle ear rubbing, and humming with emphasis on the H sound. Each of these methods targets different vagal pathways and can be used depending on whether the goal is to calm down, increase alertness, or enhance neuroplasticity. He emphasizes that these tools are accessible, require no special equipment, and can be integrated into everyday routines. Regular practice not only provides immediate benefits, but also strengthens vagal pathways over time, contributing to long-term improvements in autonomic regulation, mood, and cognitive function.